Okay, so let's look at some problems from the Module 3, Lesson 11 problem set. This lesson is very similar to Lesson 10. It's still just about setting up algebraic equations from a given geometric diagram to solve for the angle measures. It's just that the questions in this problem set are a little bit harder because a lot of the diagrams rely more heavily on the vertical angle theorem, and it can get really hard to see the vertical angles within a diagram where there's like 5 or 6 or 7 different lines and rays going off in different directions. So let me remind you that the vertical angle theorem says that if you have two lines that are intersecting, and let's say they intersect at this point that we'll call A, right here in the middle, then the angles formed by those intersecting lines on, for lack of a better way to say it, on opposite sides of the intersection point have to be equal in measure. So what I mean by that is this angle here, if I had labeled it with a 1, and I look on the opposite side of the intersecting point from there, or in other words, if I look at the other angle formed by the two lines that are intersecting, right? If I follow here and go up, I'll draw a little arrow there. And if I follow here and go down, this angle formed right in this area here must be equal in measure to the one where I started. And that also means that had I started here, let me put a 2 in this angle, that's sort of at the bottom of this diagram. On the opposite side of the intersecting point, or in other words, if I follow this line up, okay, I'll just put like a little dot there, and then I follow this line here, and I'll put a little dot here, the angle between those two dots must be equal in measure to the one where I started. So the top and bottom one are equal, and the left and right one are equal in measure. Okay, so in lots of these, you have to sort of drown out all the different lines and rays that are going in different directions and try to isolate with your eyes two lines that are intersecting and creating vertical angles that are useful to you in creating an equation. So those are the hard ones. Those are the ones I'll focus on helping you with. So I'm not going to worry so much about questions 1 and 2. I think most people will be okay with those. Question 3. The first thing I see is there's an x and a y in this problem. I want to worry about those separately. Okay, I don't want to try to build an equation that has x and y in it. I'm going to figure out what x equals first, and then see if that information helps me figure out what y is separately on its own. And so I notice that x is part of this angle here. That's a 90-degree angle because it has that little box in the corner. The other part of the 90-degree angle is made up by this 25-degree angle here. So the angle that is x degrees, I wish they put letters on all the lines here so that I could actually say angle ABC or whatever. But this angle here, I'm going to draw a green arc in it. This angle is x degrees, and if I finished drawing that arc all the way to the green line, that would be 90 degrees. So in other words, that x degrees plus that 25 degrees right there has to equal this whole 90-degree angle that they are a part of. And so I can make a very simple equation, x plus 25 equals 90. And I'll subtract 25 from both sides of the equation, and I get x equals, not 55, 65. And now look at how that information is going to help us. This part's really tricky. I'm going to continue this green line that I started here, straight down. And then I'm going to get a different color. How about this red right here, I suppose will work. And I want you to focus on this horizontal line going straight across the diagram. And now hopefully that makes it a little bit easier to see. I'm going to go back to green See this angle that I made the green arc in that has the x? It's between the green and the red line. And so if I look for whatever angle is also between this green line, the one that I'm drawing a squiggly on, not this other one, and the red line, well, that would be this angle here. And so if you try to like sort of, don't look at this other green line, don't look at this black one that's going straight up and down, and just focus your eyes on this red and this squiggly green, it should be pretty clear to see how these two angles, here and here, are vertical from each other. They're on opposite sides of an intersecting point between two intersecting lines. And so that means that this has to also be x degrees. But we already know that that's 65 because we just solved that a moment ago. And so now we have this angle here is 65 degrees, and right next to it is y degrees. And you should be able to see that they together make a 90-degree angle, just like the x and the 25 did over here. So that means that y is probably going to equal 25, but we should make an equation that says y plus 65 equals 90 degrees. And then we subtract 65 from both sides, and we get y equals 25. Since this diagram didn't give us any letters to work with, any points on the lines so that we could call our angles, angle ABC or angle DEF or whatever, then just solving for x and y is good enough on these questions. Let's look at a couple on the back. Maybe I'll do, 4 and 6, maybe 5 and 6. Let me look at them for a second. We'll see. Okay, so I'm going to do question 4 for you. So question 4 is another vertical angle situation, and I want you to focus your eyes just on this line that goes from H to G, and just on the line that goes from E to F. And try not to really care too much about the ray traveling from point A through point J. You should be able to more clearly see now that these are just two intersecting lines, and we have this one angle over here that I'll give a red arc that is 81 degrees, and it sits between the green line and the red line that I highlighted. And so that means that the other angle on the opposite side of the intersecting point A that sits between the green and the red line has to be equal to 81. So if I put another red arc between the green and the red line, everything I just arced over has to equal 81. And I arced over the part that says x degrees and the part that says 15. So that means the x and the 15 together make up an 81 degree angle. So we can make an equation that says that. X plus 15 equals 81 degrees. And then we just subtract 15 from both sides. And we get x equals 66 degrees. This one, they did give us letters on the lines for us to be able to name our angles. So I'm going to say that the measure of angle HAJ equals 66 degrees. Okay, I think I'll do one more for you, probably number 6. I'll leave number 5 for you to figure out for yourself. I put a hint on the paper telling you which angles are vertical to look out for, so that should help you set up your equation. Okay, number 5 is all about vertical angles as well. Number 6, on the other hand, actually isn't about vertical angles. It's just angles on a line. Okay, we have just a flat line, nice straight line that runs through point Q and point R. And so that means that all the angles that sit on that line, their angles create a half circle, and so that's 180 degrees. And so I'm just going to add up all the things I see, and it has to be 180 degrees. And so I see 8b minus 12, 8b minus 12, plus b, plus 2b plus 5, equals 180. You might be wondering why I didn't put the parentheses in my equation when there's parentheses in the diagram. Well, had I put parentheses, like let's say around the 2b plus 5, the only thing directly in front of that parentheses would have been this plus sign, and those parentheses would really not be serving too much of a purpose. Had this been a minus sign, then the parentheses would be super important because we'd have to be sure that we're subtracting everything inside that quantity inside the parentheses, and we would probably distribute the negative. Or if I needed to multiply that quantity inside the parentheses for something, let's say I had like a 3 here because I was going to multiply everything by 3, then those parentheses would be super important because I would need to make sure to multiply every part by 3. But when the only thing in front of a set of parentheses is a plus sign, nothing really changes, and those parentheses aren't really serving a purpose, and I knew that's how it would turn out, so I just left them off. I'm going to combine my like terms. I have 8b plus 1b, that's 9b, plus 2b, so that's a total of 11b. And then, I know this says minus 12, but I like to think of it as plus negative 12. So I have a negative 12 here, plus 5. That leaves me with negative 7. And I'm going to write that as plus negative 7 equals 180. And so if I have a negative 7 here and I want to make 0, I want to cancel it out, then I need a positive 7. So I'll add 7 to both sides, and I get 11b equals 187. And then I want to divide both sides by 11 to get b by itself, or to isolate the variable as we say. And that tells me that b equals, well, I'm going to guess 17, because if I multiplied 17 by 10, I would get 170. And then one more 17 would get me 187. So I can see that 11 times 17 is 187. So that means I want a 17 here. I'm not done yet though. I've only figured out that the variable b equals 17. So that gives me the measure of angle SPT, because that one's just b degrees. So I can write that. The measure of angle SPT? SPT, yep, equals 17 degrees. But then you got to go back and do a little extra math to figure out what the measure of angle TPR is. You have to plug your 17 equals b into the expression 2b plus 5. Calculate that out, evaluate it, and get your degree measure for TPR. And same thing for angle QPS. You're going to have to substitute 17 for the b in that expression, evaluate it to get the degree measure for that angle. So go ahead and finish that off. All right, yeah, for question 5, please look at the fact that and the line that runs through DC and the line that runs through points E and H, they're going to make some useful vertical angles for you. They're going to make this angle here that contains the 2x and the 3x, and this angle here that contains the right angle and the 20. It's going to make those vertical, okay? And that's going to help you set up your equation, but I'm not going to do that one for you. All right, good luck.